Hello, ladies and gentlemen. Welcome to the new episode of DSPy interview series. Today we have with us Prashanth. Prashanth is someone who's deeply embedded in the DSPy community, someone who writes long form articles on DSPy signature, modules, adapter, not just from the perspective of teaching, but peeking inside the DSPy code base and explaining how it sort of fits together. He's also successfully merged few consequential PRs in the DSPy code base. Prashant happens to be an AI engineer at LansDB in Toronto, and where he's working on modern storage, retrieval, and agent-driven AI systems. He has background in NLP, information extraction, graph and vector database. Welcome to the show, Prashant. It's great to have you.
Hi, Ankur. Thanks a lot for having me. Really glad to be here.
So, Prashant, off late, we have a lot of articles and attempts at sort of benchmarking JSON versus BAML versus Toon, right?
Yeah,
And you have had your own opinion on this on a while, and I've actually
right.
engaged with few of the folks who have written these benchmarks. So for the audience, today we are going to focus on looking at the work Prashant has done on sort of comparing all three of them. But more importantly, he'll also get into why token usage and looking at just that as a single sort of perspective does not offer you a full picture when you compare JSON with BAML with Toon. So Prashant, take it over.
Great. Yeah. So I think it's easiest done if I share my screen. All right. So I'm looking at my GitHub repo here. So I want to just quickly talk about the PR that I made and the history
Sure,
behind it and why I was doing it. So if you
sure.
look in here, it's basically about, I mean, if you search for the keyword BAML, I will remove the open flag. And you'll see here that, yeah, the one that got merged was in August of this year. So a bit of history on this is what I was doing and why I'm interested in BAML. And I'll briefly introduce BAML as well and how it ties into
Sure.
what we are doing here in DSPy.
Sure.
Yeah. So what this PR was noticing is that there was an issue that I created where I noticed that within DSPy, when you pass in a signature and it's the description objects and all the pydantic models inside a signature to a module, the actual prompt that is generated when you try to view the prompt via the inspect history command shows that it's using JSON schema. And JSON
Right.
schema is something like this. Here I have a deeply nested JSON object for my data models. The information that I'm trying to extract from unstructured text is
Right.
of this shape. And as you can see, it's so hard to read. Like it's an absolute garbled mess of symbols and all sorts of nested structures here for
Correct.
humans as well as LLMs. It's not just hard for humans. It turns out that it's also hard for LLMs.
Okay. So for
So
you
yeah, go ahead.
humans, I do understand why.
Yeah.
When you say it's hard for LLMs, are you just saying that the amount of serialization, deserialization would cost, and the it'll take much more time for JSON, or how
Actually,
would?
I illustrate that with an example when I go into
Sure.
the code. But yeah, I just
Sure.
want to highlight the high level problem first and why I'm
Understood.
interested in this problem, right?
Sure.
So
Sure.
this just significantly affects folks like me and many others who are
Right.
working in structured information extraction because I used to work at a graph database company called Kuzu before this. I work at LunchDB now. And
Right.
in my daily work, I end up coming across all sorts of unstructured data. And
Mm-hmm.
by unstructured data, I mean things like text blobs. Like I can very quickly show you what the data would look like. So I'm going into the GitHub code here and I have the data set. So let's look at this one here. So this is an example of unstructured data. I'm just going to make my screen a bit bigger. Here I'm showing JSON records of patient visits to clinics. And you have all this textual information here where you have
Correct.
dates and names and other kinds of things. There
Mm-hmm.
are other cases where you have images or other unstructured forms of data where I need features from that data to understand and count stuff on it. Like if I want to run queries, aggregations, and counting, I need
Sure.
structured data rather than unstructured text. So that's a
Okay.
high level problem. And when I first began using DSPy, I had come from BAML. So I was using BAML before I began using DSPy. And I
Okay.
noticed this issue with the JSON schema approach of standard default DSPy. And I'll show the example of this while we work through the code.
Sure.
So I created this issue where I point out that this is my pydantic models that I pass into my DSPy signatures. And as you can see, I have individual pydantic models, but then I pass them as nested objects to this patient
Patient object.
class. Yep. And all of this now basically has to be extracted. So what I'm trying to show here is rather than showing that garbled blob of JSON schema representation, I would rather show something like this, which is much cleaner, easy to
Hmm.
read for humans. And we'll see that from an evaluation perspective, this is easier for LLMs as well.
Got it.
So this was the history behind the PR, and then I obviously wrote the PR, the code. This uses the concept of adapters in DSPy, which I'll
Right.
introduce. And what you can see here is we import the BAML adapter, which is what I called it, from DSPy.adapt.
Right.
And now we use this BAML adapter when we instantiate the LLM call. So when you in DSPy, as you know, you configure
Right.
the LLM object, and by default, you don't specify an adapter. You just say dspy.configure and pass in the LLM object, whether
Correct.
you're calling OpenAI or OpenRouter or Google Gemini or whatever.
Got it.
But now this additional argument is here. I call BAML adapter instead of just leaving it as a default JSON schema adapter. And this will basically now transform the data according to that format.
Got it.
And the high level summary of this and why this matters is, as you can see, I've run it on many models. Some of these are outdated now. I need to update the benchmark. But basically, when I run this on vanilla JSON schema, that standard DSPy, the standard
Hmm.
JSON adapter that is used under the hood, you can see
Hmm.
here that when switching to the BAML adapter, which I'll
Right.
show now, is significant improvement in results, right? I mean,
Got it.
across this suite of models, small, large, medium, all sorts of models, you can see that there's a 2 to 5% jump in accuracy.
Sure.
So let's go into the example and I'll show exactly as I've shown, this is the notes that we are working on. I have a set of patient notes, and in DSPy code, it's quite straightforward. It looks like this. We would basically open the LLM, and to start with, I'm not going to use a BAML adapter. I'm just going to configure it as a conventional LM object in DSPy. My class now has these nested fields. So I have a patient note, which is the input, and then these are all the output fields. So I have a person name, I have an address, I have a practitioner name, immunization records, substance for allergy records, and then
Sure.
all of this now is fed into this patient object, which is a nested blob. So it's a non-trivially nested schema that we are trying to extract from an LLM.
Got it.
Now, the first point to note here, I have a gripe with a lot of the benchmarks out there and a lot of people out there who are talking about benchmarks. It tends to be that people evaluate on a very, very flat structure.
Hmm.
Now, flat structures inherently are easy because you just have one
Yeah. Yeah.
level without any nesting, and your LLM has a much easier task. It's much easier for the model to actually reason about what it needs to output rather
Sure.
than going into this deep nested structure and figure out what it needs.
Sure.
So
Sure. Just
yeah,
just on that matter.
yeah,
So 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 like, what is the right level of nesting that is good enough for a benchmark? Is it
yes.
3,
So
4, 5, 7, 12? Right?
yeah,
Because since I've worked in healthcare,
yeah,
when you look at things like lab report JSON, right, which
absolutely.
has
Yeah,
lab test, which has then the results of the lab test, then it would have inside that the reference ranges, and then deeply inside those reference ranges would be some disclaimers or adherences to government compliances saying that this reference range is suggested by the government, and then there'll be doctor notes maybe.
exactly.
So what's the right level of nesting for a benchmark to take?
Yeah. So first and foremost, the wrong level is one. For a benchmark, it does not make sense to
Yeah,
benchmark
yeah.
on the easiest
Makes sense.
example possible, right?
Absolutely.
And many of the benchmarks do that. So that's my first complaint. But yeah, talking about the right level of nesting, I would say you're spot on. Even when I work with healthcare records and all sorts of other nested data, they tend to be quite deeply nested. They're in the range of
Right.
3 to 5 levels of nesting on average.
Okay.
So I would say on average, a benchmark should have in the range of three, if not more than three
Okay.
levels. Now, beyond a point, I think there is diminishing returns.
Mm-hmm.
The deeper the record gets, the
Mm-hmm.
LLM struggles more and more as it goes further down because, as you can imagine, it has to reason a lot about the level of nesting as it is outputting the JSON, right? The task here is an LLM reads a schema in whatever format you give it, but it's outputting what
Right.
it's comfortable outputting, which is structured JSON. So
Got
in
it.
any framework that you use, doesn't have to be BAML or DSPy, it could be anything. You'll find that as
Mm-hmm.
the level of nesting increases, the performance of the model decreases, regardless of how good the model is. So I would say for reasonable expectations, 3 to 5 levels of nesting is good. In this benchmark, I think it's in the range of three. It's not going as high as five. But I'll
Got
actually
it.
talk about another benchmark that I've been studying that has a very, very good example as well. We'll talk a little bit about the
Sure.
insurance claim
Sure.
benchmark that I just worked on.
Sure. And I just want
So
to add that
to
frontier models will do much better compared to this SLM
absolutely.
small language models, right?
Yes. So yeah, we can always choose the model here when we instantiate the LM.
Sure, sure,
And here I'm choosing a medium level model. It's a Gemini 2 Flash. I could choose very
sure.
frontier recent model as well.
Got it. Let's go ahead.
So yeah, so the standard approach in DSPy applies. We create a patient signature for the input, and
Right.
then we define a module here. You'll notice here that I've defined three submodules inside a high-level module. This
Mm-hmm.
was not necessary. I just realized that as models have gotten better, you can actually send the entire nested JSON blob in one single predict method instead. You can use
Got
either
it.
a chain of thought or a predict module in DSPy. Both work equally well, in my opinion. And yeah, what this does is that you define the module and then you run the extraction function. And then most importantly, what I've done here is there is an evaluation script.
Right.
So it has a lot of custom code in here that actually maps the output from DSPy or BAML,
Okay.
and it compares the exact values with the gold data set, which is the labeled data set that I'm measuring against.
Okay.
So what this will show is basically the structured output results. Now,
Okay.
before we go into the evals, I want to very quickly run an example of what the initial pre-BAML adapter approach looks like.
Sure.
So when we run this with an inspect history command in DSPy, as you know, I
Right.
can just use the inspect history, and this will output the prompt underneath. So
Correct.
you can see here that the system message for this record was constructed this way. We are saying, okay, these are your input fields, these are your output fields with the
Mm-hmm.
type information. And then you notice DSPy does this very specific thing where you have these headers, right? You have the
Right.
structured headers that represent each section of the system message.
Okay.
And we are separating the input, which is the note, and
Mm-hmm.
the output, which is whatever object we want to return. So we have
Okay.
a practitioner object here, we have a patient object here, and already, even without nesting, here I've run each level of nesting as independent LM calls.
Okay.
And even without nesting, you can see the level of verbosity here in the JSON schema, right?
Yeah.
JSON schema is easy to generate for machines, but it is hard for LLMs to process because there is so much of nesting, there's so much of context hidden inside of all of these deep levels of nesting here. And a lot of it is kind of not useful because it has a lot of extra tokens that the LLM is not using to actually reason about what it's trying to do.
Okay.
So what we'll do next is we'll show the same thing, but now switching back to the BAML adapter. So I will enable adapter equals BAML adapter, importing from the BAML adapter class here. And what I'll do now is I'll rerun the same command, the same script. This time, what it's going to do is it's going to output the schema in the BAML format. And again, note that we're not using BAML here. We are just using the formatter of BAML via the adapter that I wrote for DSPy.
Got it.
So what this is doing now is you can see the system message above is still the same. And now the structured output field that is shown as a schema is completely different in format, right? First of all, it's easy to read for us. We can
Correct.
easily look at it and say record ID is this, name has this nested structure. Note most importantly that I have comments here. So these are
Right.
inline or header comments.
Got
And
it.
the purpose of these comments is essentially it's you take the description value in the Pydantic models. So you
Sure.
can, in Pydantic, you can give a field description as a natural language string, but
Sure.
instead of placing this information in the system prompt, which is way higher up in
Got it.
the part where you mentioned the message, you're actually placing it in a schema form here and right next to
Alongside.
the field where it is actually used.
Got it.
So, for example, if you say a phone number or a year in YYMMDD format, like ISO 8601 format,
Right.
the information about that field is very explicitly placed right next to the field. And this really
Understood.
helps the LLM to focus on the right tokens as it is doing that particular task.
Got it. Just going to take a
So, yeah,
quick pause here. I'm pretty sure the folks at Boundary would have done a massive amount of sort of benchmarking. So, do
absolutely.
they have something which folks can look at and be reassured that if they were to adopt BAML, they wouldn't have to worry and they can look at the benchmarks and sort of jump into it?
Yeah, so I highly recommend reading this blog post by the folks at Boundary. It's
Okay.
called Your Prompts Are Using 4x More Tokens Than You Need. And they've done this, I think, more than a year ago now. So it's
Okay.
a fairly mature piece of work. It's a
Okay.
very well-written blog where they talk about, again, the limitations of doing stuff via Pydantic models and what BAML does. This was not comparing with DSPy. This blog is just showing
Understood.
what
Got
they
it.
ran,
Yeah. Yeah.
and they point to a benchmark here, I believe. there's a particular benchmark in here that they mentioned. I forget, it was an OpenAI benchmark, I think, structured output
Okay.
benchmark. But this one, bear in mind, it's not a very recent benchmark. It's
That's
more
okay.
than a year old benchmarks data set as well.
Understood. No,
So
but I'm
so
pretty
what
sure
I've
they
done,
are
yeah.
running some sort of benchmarks before releasing, the changes,
Absolutely. Yeah.
right?
So the
Especially to the
format that we
parsing.
just showed, yeah, the format we just showed here has been benchmarked by them, and they have seen for themselves, the BAML folks, that this really works well in
Got it.
practice.
Okay.
So
Perfect.
I already had plenty of experience with BAML before I came here for DSPy, and I noticed that this was working well in BAML. So
Got it.
all I wanted was to bring that format here and use it, bring it for DSPy users, basically.
Got it.
Yeah. So what this basically does now is this will run the entire workflow and output the results in JSON format. And now we can run an eval script that will actually compare. And that is basically what I have shown here in the PR. The PR basically runs this on, I think, 200 records of that same healthcare data set.
Okay.
And across 200 records across the board, the BAML adapter is handsomely outperforming the JSON schema.
Got it.
And just to understand how it works. So what we do is we import from this BAML adapter class. Actually, I should show you this other case where I'm working on the insurance claim benchmark as well. I'll quickly showcase this example because it's very interesting.
Sure.
The insurance claim benchmark is a new data set that came about in this new blog post very recently. It was from this month, December 2025. And this is from a different set of folks. This is from a company called Clean Lab.
Sure.
And they found that LLM structured output benchmarks are riddled with mistakes. And
Okay.
they've listed very clearly a lot of issues with the so-called provided ground truth outputs from these different benchmarks.
Okay.
And what they do is instead of just complaining about things that don't work, they've actually identified the issues and very helpfully published their own benchmark data
Okay.
set. So it's in this repo called Clean Lab Structured Output Benchmark. They have four data sets here. Of these four, I think the most useful and interesting one for BAML's perspective is insurance claims.
Okay.
Because the moment you look at the schema here, this insurance claim schema, you can see that this is the nested schema with a lot of information in these descriptions, pedantic object
Okay.
descriptions.
Okay.
And it has a lot of useful field information about insurance claims, what information you can extract from a claim, like the header claims, the policy details,
Got it.
insured objects, the description of those objects, all of these different standardized types that you may expect in an insurance provider's data set.
Okay.
So what I've done is I've transformed this data set now in this repo that I've created into a BAML and DSPy comparison.
Sure.
And just like the previous healthcare example, I
Mm.
import the BAML adapter. Now, sorry, I'm looking at the same example here. I need to go to the other one. Insurance claims. Let's look at this one here. Yeah. So it's basically using, in this case, I'm trying out Gemini 3 Flash, which just came out
Mm-hmm.
last week.
Mm-hmm.
And then I run a extract claim on this complex pedantic schema that I just showed in
Okay.
DSPy. But simultaneously, I also do the same in BAML. Now let me very briefly introduce BAML and show what I'm comparing against. BAML is, let's go to their website. So if you go to the boundaryml.com website, they're essentially calling themselves a language for building agents, but for all intents and purposes, it is a primary interface to LLMs. And
Correct.
what by that I mean, you in BAML, you define your LLM client that you want to work with. So
Mm-hmm.
here I can say I'm using an open router client and I specify all the input parameters like the model name and so on, Google
Got
Gemini
it.
3 Flash.
Got it.
And then what I do is similar to how I did in DSPy with Pydantic. I create this data model in BAML. It's in
Only
this
props.
.baml file.
Understood.
And BAML has its own type system. It has a very concrete, strongly typed system.
Right.
So you can define things like enums, what are the equivalent of literals in Python.
Right.
So in all these different things can have different naming conventions. You can have like for channels, you have this, for coverage type, you have all of these. So these are all standardized insurance terminology in this data set. And you can expand on this to an arbitrary length, right? You can have any
Right.
number of enums as you want.
Got
And
it.
then I can have nested objects. So I define a claim header that has all these fields. Again, just like Pydantic descriptions, I can have descriptions in BAML in
Got
natural language. And again, you can see here that I provide information about data extractions. I want it in this format to be very
this.
explicit about what I am expecting as output. And then I go into this playground where I can actually write a function that calls an LLM. Like I'll show you the example of what it's doing. So I have this insurance claim extraction that is outputting this insurance claim object, which is this deeply nested blob. So
Okay.
it's calling the defined BAML types in here. And I specify which LLM I'm using. I'm using Gemini 3 Flash. And
Okay.
all I have is this one-liner that says extract the insurance claim from this following text. That's all. It's just one line prompt.
Got it.
And then this stuff here is a templating language in BAML. It uses its own templating language. So basically, you just say, okay, this is the output format that I expect in that language. And this is the user part of the message. And this is the input text that I am giving you. So when I actually show this, what's happening under the hood is BAML is transforming this typed system here, the type code that I've
Right.
defined, into a prompt on the right here. The
Got it.
system message is here, and then all these are enums that are defined. These are the possible values for these enumerations. And
Understood.
then I say answer in JSON using this schema.
Got
So
it.
notice here again, it has comments placed right next to the fields, and it also has all the levels of nesting that I would expect.
Got it.
So then I have the user message which has the text. And you can see I have a very long form string here with
Right.
information about like unstructured text of a property claim from this person, Jennifer Garcia, and all the other stuff that's
Got it.
related to that claim. So the powerful part about BAML, just like
Just
DSPy,
one
is
thing, the
yeah,
data that you have here, that is
yeah.
written by you, or it's just dynamically generated by introspecting uh,
No,
the
so this data is basically coming from this test
ah,
case that I wrote. So I'm
so
just
it's
going to go into
tests.
that.
Understood.
Yeah.
Got it.
Exactly. So BAML is a very test-focused, testing-focused framework. So
Understood.
when you actually write a function, you are encouraged to write a test to run it on some real data
Understood.
just to verify that what your prompt is saying works.
Got it. Got it.
So what I'm doing here is I'm defining which functions go into this test, in this case, this extract function. And
Right.
the argument here is just this free-form string that I got from my goal
Right.
data set of the Clean
Right.
Lab benchmark. And I'm running a bunch of asserts here to verify that each of the sub-levels of nesting, header,
Right.
policy number, insured objects, and descriptions are extracted in the output.
Got it. Understood.
In the playground, the BAML provides this useful feature where you can actually inspect the results on the fly without writing any code. So you just write
Got
the
it.
BAML model, and you see the raw LLM response came out in this format. BAML has a
Right.
parser that actually looks at the output and
And
coerces the types in there to the expected outputs and
got
errors out if things are not conforming to the type, similar to how Pydantic does it in DSPy.
Understood. The good thing about this is it's kind of quite visual. And
Yeah,
one thing that I could realize is, let's say that there are a couple of traces that have failed in production. All you need
exactly.
to do is copy paste, bring it here, quickly have a look at what's happening, and sort of see it for yourself. Yeah.
It's a very, very quick way of understanding what works and what doesn't
Yeah.
work. And the good thing about the testing here is if I'll just mess up this test intentionally and I'll
Sure.
rerun the test,
Yeah.
and you'll see now that the assertion will immediately fail and complain about what failed. It'll tell me
Got it.
here the assertion failed, and somewhere down it should mention which assertion failed. Well, I guess it's not showing it here exactly, but yeah, in theory it should show you the
Sure.
exact assertion that did fail. But the point here is that this helps you very quickly understand, okay, my prompt is actually doing the job that I expected it to do.
Correct. No, this is
So,
pretty helpful. Yeah.
so I want to very quickly showcase how this would run. So what I'll do is I'll go to the directory here. So I go to my SRC, CD, insurance claims,
Hmm.
and I have two directories, BAML and DSPy. So let me CD to the BAML directory first. And note that I just shown BAML code, right? So how do you run
Right.
this in Python? So the power of BAML is that it essentially runs, it generates client code in any language that you choose. So I'm choosing
Yeah.
Python here as a language. So it generates this
Sure.
client directory that has all these BAML
Okay.
types translated into Pydantic types.
Okay.
And now I can run a BAML Python script where I import from this client library. So I have this BAML client. I
Okay.
import from its async client generated code. And now all the objects that I've defined here in the BAML code, the type system and everything, is
Hmm.
translated to its equivalent Python types. And I can just run a simple Python script to say extract claim that I would normally write in Python.
Understood. This is super
And
helpful.
super helpful, right? So let me run that really quickly. So I'll run here this extract file. I'm just going to run it on the entire data set. I just have 30 records, and
Sure.
this is running asynchronously. So you'll see how fast this runs. I'm running this with a time command. So it's running a bunch of records asynchronously calling Open Routers API or whatever API you choose. And it's run this in like hardly 6 seconds over the 30
Mhm.
records. And all of this is using one LLM call per document. So what I'll do now is
I'll take a quick
yeah,
pause here. One thing I realized, that one of the benefit of going in with a BAML first approach is that, later on, as you make everyone who is working at some scale and has LLM interfacing code and sort making changes to the prompts or switching models, one of the things you have to do is run your test suite and just see that, okay, are all my
Exactly.
test cases working or not? So if you adopt this BAML first workflow, uh, I mean, this just becomes part of your sort of workflow before you take any change live, right? So you don't have to write
Absolutely.
another sort of library and sort of do the testing. This
Absolutely.
seems
That's a very good distinction, and I'll show how DSPy differs in that approach here. But
sure.
in my head, they are both equivalent in the sense that depending on your frame of mind and what you're trying to do, you can use
Mhm.
each of them for the same task
Right.
in a very complementary, sorry, in a very similar fashion without actually
Sure.
overlapping
Sure.
the two.
There's one more
Yeah.
benefit, a
So,
lot of folks have
yeah.
microservices in different languages, right?
Yep.
And so the common thing that could tie them down is that you can have all the boilerplate code that you are going to write, let's say in Go or something else, with
100%.
the same
Yeah.
sort of structure being generated, and you don't have to. Yeah, this is helpful. Let's go ahead.
I think that's the biggest selling point of BAML, to be honest. Like the fact
Ah,
that
okay,
it generates client code in pretty much any language means that now everyone in any language can have access to LLMs without writing Python code, basically.
got it. Yeah.
So, so what I'll do now is I'll run an evaluation script that I've written here. The eval script is provided in the same directory. The eval script, all it does is it flattens all the records and compares the
Sure.
goal data set to the data set that BAML or DSPy generated.
Sure.
So UV run, evaluate. Now I'll expand this window a bit so we can see it. Rerun that. Yeah, so it's run it over 30 records. And you can
Mhm.
see here the output script is saying, okay, which particular fields it failed at. And it's giving your total score here, 89%, right?
Okay.
So it's basically telling me that, okay, in these particular record IDs, there are mismatches and these things did not work out. The insured objects is in the deeply nested. As I pointed out, some level of nesting can affect the overall outcome, right?
Okay.
So this tells us that, okay, there is scope for improvement and the improvement can come from many places. It doesn't have to come only from a better model. Of course, a better model can potentially give you better results, but there are other ways you can improve it. You can actually focus on writing better prompts, restructuring the prompt. There are many ways you can think about what a prompt even does in the first place to actually get you that output.
Okay.
So that is where I think the experimentation mindset comes in. You have an eval, you understand what the baseline performance is, and the eval here, by the way, is checking for a non-trivially difficult task. So it is
Okay.
basically not checking at a flat level like many of these benchmarks that we see do.
Understood.
And what I'll next show is I'll go to the DSPy directory and run the same code there. And just to show you what I'm doing in DSPy, it's exactly the same logic, right? I have my pedantic models defining what I want in the
Right.
schema file. So I have
Okay.
the exact same model that I had in BAML, but I've written the pedantic model here for DSPy myself. And this is how anyone working in DSPy would do things. And then in the extract script, I will just run the same exact command again. So UV run, let's time it as well. This is also going to run extract in async.
Okay.
So it runs pretty
Wow.
quickly.
That was
Actually, this one I think is using the
I think it's
cache, so I
cache,
wouldn't
right? Yeah, yeah,
trust
it has to be cache.
exactly. So you have to send a command into the LM here to
Yeah, yeah.
disable the cache
That's
and whatever.
okay.
Like it's yeah,
That's
it'll
okay.
be in the same order of magnitude. It's maybe slightly slower than BAML in my experience, about maybe
Got
2x
it.
slower because just it's BAML is written in Rust and DSPy is not. So yeah, basically now I'll run the eval function. And you'll see here, yeah, we're in the same order of magnitude. I have the exact same results. Now, there'll be a plus or minus difference in the quality of outputs depending on the model.
Just
In my experience, I have seen, yeah,
so
go
one
ahead.
thing, no, one of the most troublesome for both was that getting object ID. Object
Exactly.
ID is probably the worst performing for both of them, right? But BAML seems to be a
Yes.
little better than what I see here. Anyway, please
So
continue.
I think there are definitely ways in which we can actually improve on the way we specify the prompt and
Got it.
the way we format the object IDs and these other things. So
Understood. Got it.
this is exactly what I want to lead this into, which is when
Okay.
you have an eval-driven approach, right? It doesn't matter what framework you use. Both BAML and DSPy allow you to test out your ideas
Correct.
by using a strictly typed approach. I think this is the most important thing. You want to involve a type system in a way that you incorporate the types as part of your extraction process and you're having some sort of validation downstream. DSPy and BAML both have their own validation mechanisms downstream. And the way the DSPy works, by the way, is you can very quickly inspect it. You import BAML adapter from the BAML adapter class in here in the code base, and then you that itself inherits from JSON adapter, which inherits from chat adapter. And as you know,
Mhm.
chat adapter is the default adapter in DSPy. let's take a step high level above this. What is an adapter? I think that is what people need to understand here.
Yeah, sure.
The fact that you have a signature in DSPy, right? The way we define the signature,
Right.
where was signature defined here? Yeah, this one here. So the signature in DSPy is the unit of prompting an LLM, where you give it this docstring or a user instruction here explicitly in natural language, and then you specify the input and output types via the type system.
Got it.
The signature is very, very high level. It is meant to be declarative. All it does is provide the user an interface to express their ideas and logic to the LLM in a very simple and intuitive way. Similar to
Right.
how BAML does it with functions. BAML has a function abstraction, DSPy has a signature abstraction, and both are functionally equivalent. They kind of do the same thing, combining type systems with natural language.
Got it.
Now, DSPy kind of hides the complexity of what happens under the hood via the adapter. The
Right.
purpose of the adapter is to take the declarative instructions in the signature and
Mm-hmm.
transform that into a form that the LLM understands.
Got
So
it.
that is exactly what all these adapters are doing. The chat adapter and the JSON adapter and the BAML adapter, all of these adapters, they basically implement these methods under the hood where they format field structures, field descriptions, user message content, task descriptions. Like all of these methods are implemented, and in BAML's case, BAML adapter's case, it overrides the chat adapter's methods for specific cases by
Got it.
using the Pydantic information and transforming it to the BAML format. So
Got it.
that's why it kind of inherits the base class, but then overrides specific methods to work for the BAML format.
Got it.
So all it's really doing is essentially transforming the data from the signature, transforming the instructions from the signature into a form that is used in the prompt.
Got it.
So, what the if you're interested in learning more about this, I actually written about this at length in my blog, and specifically in part two, where I
Correct.
have this diagram where I talk about the different pieces of DSPy. You have the concept of signatures that depend on adapters, and the module is what uses the signature and the user instructions from the signature, which calls the LLM and gets the output for prediction, which is used for evaluations downstream. The part that I think is like I guess hidden from the user and the way the DSPy maintainers have designed this is the adapter is meant to hide the complexity. The purpose of the adapter is to allow the signature and module to generalize to any model paradigm. So today we work with LLMs that take in prompts of this nature. We have a structured prompting approach in DSPy, and the adapter formulates it for this paradigm. In the future, if we have other model paradigms and how we interact with those models, we'll have new adapters that kind of handle that. So that's kind of the real purpose here. It's kind of a pluggable, hackable way of allowing the user to tap into whatever way they want to convey the instructions to the LLM without actually making the high level interface really, really complex.
Got it. So on a high level, the adapter is doing your
Yeah.
communication with the LLM model itself, deciding whether to, have the JSON based communication or an XML based, or like all the parsing and the formatting would be done there. So that's two. Third would be
Yeah,
all
just
the
to clarify the first point, it doesn't communicate with the LLM. The module is the sole communicator with the LLM here. The
okay.
adapter
Okay.
just is tightly connected to the signature and formats the prompt appropriately.
Okay, got it. All right.
Yeah,
So there are different types of adapters that are already shipped along with the one that you committed, right? So one would be there is JSON chat adapter, right? Then you
yeah,
have
yeah.
XML, and what are the other adapters that come out of the box?
Yeah, so we can actually go into the code here and look at if you look on the left side, we have a
Right.
directory structure in the source code of DSPy. This is
Yeah.
in the main repo as well. So you can actually see that we have chat adapter,
Chat
two-step adapter,
JSON
XML
XML.
adapter. Yeah.
Got it.
So I think what we're trying to note here is that you don't need to have what adapter you want in here. The beauty of this whole system is that you can
Yeah, you
write
can
your own
import
custom adapter that
and have it
yeah,
in your own repo.
exactly,
So
exactly.
that's what some of the
The
folks have
reason
done for
BAML
me.
adapter got merged yeah, the
Right.
reason BAML adapter got merged, I think, is because of the significant improvement in performance compared to the JSON and chat adapters.
Got it.
So
Awesome.
there is also an XML adapter which you can use to format XML type signatures. Personally, I don't prefer using XML because it is way more verbose.
Mm.
The BAML format is way more compact and token saving compared to this.
Right.
So we'll come to the trade-offs of that token saving versus performance when we talk about two. So
I
yeah,
just
in a
just want
nutshell,
to
I
add
think this is yeah.
just want to add one thing here, that historically a year back there were a lot of people who would consider XML based format because
Yes,
in those days the error rate for JSON used to be much higher across models, right?
exactly.
But now with passing time and the amount of improvements that happened at the side of large language model in terms of building layers just for structured output and guaranteeing JSON responses against schema that you supply, I think now people have
Exactly.
kind of not sort of, I mean, the structured output error rate has gone down significantly for people to not worry about, going with XML or
Absolutely.
would that be a
So,
correct
so
sort of,
it's a very correct statement, and the reason for this is nowadays we have libraries or toolkits that actually do
Mhm.
JSON repair. So if you look at DSPy's internals, you can see here inside JSON adapter we have this
Right.
module called JSON repair, and this
Hmm.
is actually a third-party library on GitHub. If you actually
Right.
see the code for this,
Yeah, understood. Hey, just want
JSON
to add one
repair,
more thing to that. I
yeah,
think just
yeah,
last week, Open Router, they sort of gave this guarantee of repairing JSONs, which have sort of
yes.
malformed, formatting, malformed closure of parentheses, etc., and sort of
Totally.
repair.
So you're spot on that today, I think we rely on third-party plugins or libraries to do this. BAML
Mm.
implemented their own JSON repair functionality. They have their own internal Rust code base that does that.
Got
But
it.
you're right in the future that LLM providers are getting much better at fixing JSON on the fly and giving you good quality JSON as output. So
Yeah.
parsing becomes easier and easier as models get better and better over time.
Right. Right.
Now, there's one important thing I do want to touch on regarding the structured prompting strategies.
Sure.
Recently there was this paper that came about structured prompts like from Stanford. This one here, structured prompting
Right.
enables more robust evaluation. So I actually was very inspired by this paper. I'm surprised that this was not published earlier because it's so important to understand
Yeah.
what the findings are from this paper is, and why I'm using it in my informing my work is the way DSPy approaches prompting, as I showed you, has that structure to it, right? It has a header with those square braces and hash symbols and all the other stuff there.
Right.
So what the paper is saying is that when you compare across frameworks for any
Mhm.
benchmark, let's say I'm comparing BAML and DSPy, to do a
Right.
fair comparison, I need to have prompts that are more or less structured the same way as well. It's not just the language of the instruction, it's also
Got
the
it.
fact that adding structure to the prompt allows
Hmm.
you to have less variability across different models.
Got it.
So the reason people are so scared of switching models in their experiments is that
Hmm.
when you switch a model, you cannot predict how the model perceives the structure of the prompt and the tokens in that prompt. Every model perceives those tokens differently.
Right.
So what this structure does and the way you formulate the prompts, like you give it this kind of predefined sort of template. Your input fields are
Mhm.
this, your output fields are this is your objective, these are the types. So when you have a like a standardized structure that you have, like DSPy has, you see that, like I've seen this personally firsthand as well. The
Mhm.
variability across LLMs is less in DSPy than it is in something like a BAML or something else, where you don't have that imposed structure. So
Got
I think this is a lesson for the industry where having some sort of agreed upon prompting strategy with the user instruction is fluid and flexible, but the overall layout of the prompt is more or less agreed upon that these are the things we need to actually put in. And note that type systems are crucial here. These are the fields, these are the outputs. You need to specify types as part of the prompt because if you don't do this and have a loose string that just asks for things without specifying what types are in there, there's a very high chance that it will deviate from what you want and give you unparsable outputs and it'll break all your workflows downstream.
Got it.
So right now we don't have the standardization, but this paper is actually really great. I actually have been using structured outputs without realizing it, even in BAML sometimes, where I go into my BAML code and I actually write very, like XML style tags or DSPy style, square
Right.
braces and stuff like that in my prompt to make it much more robust to
Sure.
change across models. So I hope this is the takeaway that people have that BAML lets you write prompts in a very, very fluid and free-form way. But
Right.
bear in mind that having this templated approach of structuring your prompts will reduce the overall variability across different models.
Understood. This makes model switching much easier, and you can go ahead with confidence and sort of switch and see for yourself how
Exactly.
it's behaving and performing. Got it. Okay.
Exactly.
So we talked about BAML, JSON. You sort of gave us a good walkthrough of how BAML works end to end. Do you have what's your thought on Toon?
Yeah. Okay. So just to very quickly summarize and go to Toon. So as you've seen here, I can have any arbitrary models extracted, specified via the BAML syntax or via DSPy syntax, right? So
Sure.
in this case, I have all these complex schema objects that I've written here. I'm just going to put them side by side so I can see it. So this was my Pydantic model for DSPy, and on the right side, I have my BAML models. It's just a user preference as to what they want to use. If you're already working in a Python environment and you use DSPy, the functionality is equivalent. You would
Hmm.
go about the same approach, define your type system, pass it to the signature. In BAML, you define the type system, pass it to a function.
Right.
So this is really powerful in terms of the formatting. We brought the BAML formatting mechanism into DSPy via the BAML adapter. And so
Okay.
what the natural next step and what people have tried to do is use the tune adapter. Just to clarify what tune is, let's go to their GitHub. So I'm sure people have heard about tune and seen
Yeah. Yeah.
enough talks about it.
Yep.
But
It looks like, I
what
mean,
the
everybody
interesting
who
thing
looks
about,
at, just to
yeah,
add, everybody who looks at Toon, the first thing that comes to their mind is, hey, this is CSV, and we've been using this for
yeah.
ages, and there's absolutely no reason why that. I mean, why didn't people think of this from the get-go, right? From an intuition point of
Absolutely right. And you see here like the data that is nested and has
view.
all these arrays. What Tune is promising is that you can actually define this array in a very concise way and turn that into a CSV kind of representation. Like it's
Right,
transforming the nested JSON into a tabular sort of representation.
right, right.
Now, on paper, this is great because it saves tokens, and everyone's raving about the fact that, oh, I save like 40%, 50% tokens.
Yeah,
But you'll see on their repo itself that it's they themselves, the Tune people say that do not use Tune when you have deeply nested on non-uniform structures where
right.
tabular eligibility is not there.
Got it.
And JSON compact is what they call it. I think JSON compact is just a pseudonym for BAML format. There's no
Okay,
official terminology as to what BAML names its format, but JSON compact is kind of like a compact representation of this JSON object where you
okay.
don't have these extraneous
Oh, okay.
quotes and other symbols.
No spaces, nothing, just
If you
absolute.
remember, yeah, if you remember BAML's syntax, it was
Yeah,
kind
yeah,
of
yeah.
that as well. If you actually look at
Understood.
their code and you go to their playground and you see the
Right,
way they formatted it, this kind of
right.
looks like JSON, but it doesn't have double quotes and all the extra symbols. So I would call it
Understood.
JSON compact for all intents and purposes. So
Got it.
Tune themselves say that JSON compact is recommended when you have nested JSON.
Hmm.
And what I've done is in this repo itself, I've actually created a branch. So let's call it,
I just want to add something here while you're running
yeah,
this. One of the things
yeah,
that sort of social media has, or I would say rather, you have a lot of influencers who have good amount of reach, right?
yep,
And it's like they're continuously feeding that sort of, should I say, engine, right? That got them there. And as part of that, you have to
yep,
push out content. And you had a lot of these
absolutely.
posters about Toon and a lot of numbers being shared, and so I think there's a lot of misinformed sort of propagation of ideas, and you have a lot of folks who would just take that as face value and go with it as default without actually
Exactly.
having any sort of benchmark to look at. And yeah, and I say that because I don't recall any of those influencers actually talking about from the very GitHub page when it would not work, right? I mean, it was like the
Right.
next big thing is here and you shouldn't even go back to JSON.
Seriously. So I think there was a lot of initial overexcitement about the
Yeah.
Tune format. So yeah, essentially, I think I have not yet merged this branch, but
Go ahead.
basically, there's a new branch I've created here in this one,
Okay.
and all it does is in this patient note example, it
Sure.
basically has a tune adapter that is adopted from this actually external library DSPy tune.
Okay.
So I'll very quickly talk about DSPy
Sure.
tune. It's a GitHub project that came about. I forget the contributor's
Who's,
name, but we can check
let's,
this.
no, let's
I,
just give him
did you
the.
did you did you speak to them already?
No, no, I did not. But can you tell me the name of the person?
Okay,
I think Michael did it, right?
Michael. Yes, yes, yes. Michael is his name. My
Michael,
bad.
yeah, I had a conversation with Michael. Yeah, yeah, we did talk about Toon as well. And at that point of time, he was still underway with the benchmarking and he had not completed it. I don't know what is his conclusion at the moment. I'll check with him, but
Yeah,
got it.
for some reason, Google is not able to find it. Why is Google like if GitHub
Okay,
search, I think on Google is just not working. Yeah.
I'll tell you
So
if you want to find him, you
yeah,
can just search on GitHub.
yeah, yeah. So anyway, so what I've done is I've taken the code from that repo, and this is basically Michael's code. It's not my code. So all it does is it uses the same adapter mechanism. Instead of writing a DSPy, sorry, BAML
Sure.
adapter, it now writes a Tune adapter.
Understood.
Because Tune does not natively support inline comments, which I think is a huge omission. I think we
Yep.
need support for comments like BAML's format allows.
Understood.
This one actually adds comments to the tune format as well. But
Mm-hmm.
in the experiments that I've been running on this branch, it just does not work for nested JSON. And
Got
if you go to the original Clean Lab benchmark, the one that they've created in this one,
Right.
out of the four data sets that they've published, three of
Mm-hmm.
these don't have nesting. Like if you look at the financial
Okay.
entities one, like this is the simplest, flattest schema that you can possibly
I
use.
think these don't even help, right? Like, I mean, might as well not.
So the issue here is that Michael himself, I think he also noticed this. He ran this benchmark with Tune, and Tune does well on this flat structure.
Got it.
When you
Understood.
have flat data and you have a very laser focused narrow case that
Mm-hmm.
needs information extraction on that data, Tune may work
Mm-hmm.
for that use case. But
Sure.
general purpose nested data, it's just not working. I get all sorts of parsing errors. The LLM does not understand the task. So
Mm-hmm.
actually, the real high level takeaway and the main thing I want users and viewers to take from this is
Got
the power of this whole benchmarking approach, right?
it. Mm-hmm.
You start with a clearly defined task and
Mm-hmm.
you write the benchmarks and evaluations as a first step.
Got it.
This entire repo is actually very well thought out in the sense that this utils function actually has all the evaluation code
Got
and
it.
processing the data for
Right.
comparing LLM outputs to given goal data. So
Understood.
by starting with this benchmark, the approach of storing data in a benchmark
Mm-hmm.
and evaluating it upfront to get a baseline, just like
Right.
machine learning was always done, right? When we did
Right.
classical machine learning, we have a baseline, we run machine learning models, and we prove that
Correct.
the trained model is better than our
Better
baseline.
than the, yeah.
So so this is what DSPy and BAML both bring to the table, where when you have this
Got it.
testability and ability to evaluate your pipeline, you think
Mm-hmm.
from an eval standpoint as your first step. And I think structured outputs is a classic case for eval because you have exact match as the criteria. You know exactly what you expect as the output. So
Got it.
you should be really focusing on evals and writing this sort of a framework and approach this way. And immediately start iterating by comparing against your baseline. Do not
Sure.
have a loose system where you switch models and don't know the impact of what the switching model did.
Sure. Prashant, let's do two things.
Yeah,
So one is
yeah,
let's look at also Kevin's benchmark that he published. Although it didn't have nested JSON, I think those numbers would sort of also add to this conversation. The second thing that, while
okay,
you were speaking, I kind of realized that let's assume for a moment that, there are a bunch of folks who are using LLM and they are very confident that the structure would remain flat forever or for the vast
yeah,
amount of time, right? So I think in that case, if
yep,
they go with something like Toon, they get the kind of token less number of token required or the benefit that Toon offers. If someone is very clear that this is a long running project and there will be nested JSONs, etc., and it's a complicated bigger project with a lot of LLM interaction, maybe they should go something with BAML which has all the workflow end to end and sort of makes it easy, right? So I think there is no one size sort of fit all, but yeah, I'll be very skeptical of Toon because there's definitely some amount of fad with it, right? And you don't know how
yeah.
long it will last, right?
I fully agree with what you were saying about people are jumping onto formats without really thinking about what they're evaluating. I think that is the main takeaway here. Think about the evaluations. Format is just a means to an end. And
Right.
now both DSPy and BAML have clean ways of formatting text for structured outputs in a very useful manner.
Awesome. So Prashant, thanks for giving us the entire sort of tour of how BAML works, showing it how how the type system is and how the entire integrated playground-based approach is. So this got me thinking, uh, like how do you evaluate that? Okay, for this product or this project, I'm just going to use DSPy, and for this one, let me go with BAML. So what are your thoughts on that?
Yeah. So for me, I think both DSPy and BAML are, in my head, functionally equivalent. And by that, I mean they provide very similar primitives to do a variety of tasks with LLMs. So they
Okay.
kind of are the low-level building blocks for agents above them.
Hmm.
And I think where I would choose to use BAML for a project over DSPy is two things, where I really need production grade, high performance, a lot of deployment related aspects where BAML is super tested in production.
Okay.
Um, and also the other reason of using BAML is if the end user is not using Python. So BAML very easily integrates with all these other languages. It has its own language, but generates client code in the language that the application is written in.
Got it.
So
So
it's
you don't
very
have to write
powerful at
any of the
that.
boilerplate.
Right. Yeah. Yeah. So it saves the user time when they are porting over to these other languages and applications are not in Python, and it doesn't force the user to kind of come into that Python environment. In DSPy's case, I very much be interested in continuing to use DSPy for a lot of things, because I think DSPy is at the bleeding edge of this entire space. It is experimenting with new techniques on optimization, writing better evaluations, and I've seen a lot of interesting ideas from the DSPy community on how we can get better training data for optimizers. And whenever a new optimizer comes out in the ecosystem, it is likely to be plugged into DSPy first before it ever goes into other frameworks like BAML. So right now, BAML implements its own flavor of JEPA, but
Mm-hmm.
they've stated explicitly that their goal is not to be like a batteries included optimization framework. They will
Got
provide an opinionated approach to optimization within BAML for users who want it. But
got it.
DSPy will be always that, highly flexible, pluggable, research focused ecosystem that is at the bleeding edge. Personally, I would want to be in both camps and follow both communities closely. I really love working with both of them.
Got it.
And I think users can make the call for themselves depending on what they're trying to do for their applications.
Got it. That's helpful. And I just want to add that, there's a saying, nobody gets fired for buying IBM. So, if you are in a large organization and you want somebody to be offering you support, somebody to offering, being
Exactly.
able to talk to your developers, right? And so I think in that sort of scenario, a company like Boundary, sorry,
Boundary.
makes for a better choice. But at the same time, I think the frameworks and all are evolving at such a fast pace
Yep.
that maybe if you just want something low level and you're a data scientist, then probably DSPy is something to go with. And like you rightfully said, it's for the users to decide based on their circumstances and organization challenges and sort of style of operation, what is a better fit for them.
And can I can I, can I,
Yeah,
can I
sure,
can I
sure.
also end with a hot take, a little
Yeah,
slightly hot take?
yeah.
So
Sure,
so the
sure,
thing is, there's a philosophical difference between DSPy and BAML, and I
sure,
think people need to understand that as well when they consider what they're trying to do.
sure.
BAML is opinionated on the fact that prompts are explicit and editable by humans.
Okay,
So you go into the function, you write parts of the prompt yourself, you
right.
engineer the prompt in a way that you get the output so that your tests pass. So
Correct.
it's a software engineer driven way of thinking about AI and how
Mm-hmm.
to work with code. DSPy is thinking from a very declarative AI spec perspective. And
Right.
Omar has tweeted a lot about these things where the prompt is kind of a layer beneath the signature.
Right.
And the declarativeness of the signature means that the user is not manipulating prompts by hand. The
Mm-hmm.
DSPy specifies that structured template that I showed. So the philosophical difference here is that DSPy does not want users to manipulate the prompt directly. BAML does. And they've been explicit that they want the user to do that. The I guess where the seesaw happens is sometimes humans tend to over-engineer prompts. Like just
Right.
like we've over-engineered
Yeah, yeah, absolutely.
assembly code and other systems in the past, like
Mm-hmm.
very, very low-level things at systems level. I think that's happening with the prompt engineering ecosystem now. People are over-engineering prompts. Now, the BAML camp is all about we want to let people do whatever they want with their prompts, let them be
Right.
customizing it the way they want. If they have domain expertise, they can write very, very detailed prompts.
Correct.
But the DSPy camp is that optimizers will help discover those prompts.
Correct.
So the I guess the tussle in the ecosystem now is which approach is better for which use case, right? It's
Mm-hmm.
not clear today that prompt optimization will indeed always outperform human engineered prompts. There are
Right.
cases where a very heavily and human engineered prompt outperforms something that JEPA discovers, right?
Got it.
Now, where it gets really interesting, and I think Chris Potts has mentioned this in a couple of talks, is
Correct.
can we actually head towards an optimization ecosystem where we don't rewrite the entire prompt? Right now,
Mm-hmm.
JEPA will rewrite the entire prompt
Yeah,
based
yeah,
on what it discovers
absolutely.
in the prompt space,
Yeah, yeah.
right? But if we can bake in human domain knowledge that we provide into
Mm-hmm.
the prompt logic, where the prompt is actually the algorithm that writes the prompt is baking in the human domain knowledge while it also optimizes for the verbiage of the prompt for that model.
Mm-hmm.
So I think the blending of those two worlds is not there yet, and I think the research needs to push in that direction. So in who knows in the future, you may have a unified world where both the BAML approach and the DSPy approach are actually compatible, or people actually think about prompts in a very holistic way, rather than this black or white approach that we have today, which is you either write the prompt or you just don't write, like let the optimizer discover the best prompt.
Got it. The way sort of if I were to summarize what you're saying and let me know if I got this right, DSPy is a inch wide and a mile deep, and BAML is trying to be, sort of a mile wide and offer the entire tool chain and everything, and not really go a mile deep on the optimization bit, right?
Yeah, I think yeah, optimization is definitely not like they only provide it for very specific reasons,
Got it.
whereas DSPy is pushing the boundaries of what we are doing, and I'm actually very eager to see where both go in the next year. I think 2026 is going to be a very interesting year for both tools.
Yep, yep. So Prashant, thanks for taking time on a Sunday and walking us through BAML and sharing your thoughts. It was great talking to you.
Yeah, thank you so much, and please find me on Discord. I'm on BAML Discord, DSPy Discord, all Discords. So whoever is on there will know who I am. And yeah, looking forward to chatting with you and many others in the community.
Thank you, Prashant. Have a nice day.
Thank you. You
Bye.
too.